afternoon. I'm going to stand a little bit on the side here. Thanks, everyone, for being here, and welcome. This is our Modeling to Policy event, Circular Economy Pathways Towards Net Zero. We're bringing today people who work towards the same goal. Basically, we all know that circular economy is an underexplored lever for climate change mitigation, and we have here researchers looking at data analysis models, writing papers, but we also have policymakers working on negotiations and bringing all of this to the real world. So we're basically working towards the same goal from completely different lenses, and we don't usually get to see each other and talk, so I think it's a really nice opportunity to be here. I haven't introduced myself. I'm Mariana Zotin. I'm a researcher at Utrecht University working in CIRCOMOD, one of the projects represented here today. And I'm going to walk you through the program now. I also want to thank the people online. I heard that there's many people watching us in this first plenary. And so first we're going to start with keynote speeches from the representatives of the EU Commission and the PIs of the three Horizon Europe projects. Then we'll move on to a high-level policy exchange panel where we'll have presentations from the three projects, the main messages, and later on, after a coffee break and a chat, we'll move to three parallel breakout groups where we'll deep dive into those same topics, which are construction ecosystem, service-focused measures, and system-wide enablers. So I'm going to be facilitating the first session now, and I would like to invite to the stage first the three PIs, the three, or later. Okay, first I would like to to invite them. William Neale, who is advisor on circular economy for the DG Environment. Thanks for joining us. William is a key person for the circular economy plan in the EU and is really important for bringing the numbers and really knows the importance of the importance of circular economy to climate change mitigation. And we also have here Vicky Pollard. Yes, please. And Vicky Pollard is the head of unit for Foresight, economic analysis and modeling for DG CLIMA. She's been involved with climate negotiations for the EU since 2006, and she basically runs the unit that is responsible for the numbers behind the EU climate target. So I'm really happy that you're both here with us, and please welcome. You have 10 minutes together. I'm boycotting the World Cup this year, but I do like football, so I brought my cards to control the time. This is 2 minutes, and this you're out. Thanks again.
We're going to come up here to be more dynamic.
Yeah, sure. Nice. Okay, thank you.
Thanks.
Well, thank you very much. Nice to see a few familiar faces in here. And I think I was speaking at one of the first meetings of at least one of the projects that's being talked about here today. So, I mean, I think in this room we all know and we all understand that optimal materials management and use is essential for reaching our climate objectives. If we ignore materials, then we ignore a major part of emissions, a major cause of our vulnerability. And even with renewables, energy efficiency, and so on, the actual transition to net zero will itself be rather material intensive. So might seem fairly obvious to us, but I think to many policymakers it's not that intuitive. And we are working, in my case, a lot on intuition. We don't want to arrive at a place where we're doing policy-based evidence making. So that means that we need robust quantification as we build up our policy approaches. We need credible estimates. So basically what I'm saying is what you're doing in these 3 projects is super important, and it's not by accident that I'm here today, because I really want to listen. To give some examples about the processes that we go through, and I mean, when I'm talking to colleagues in the Commission working on completely different policy areas which might be connected, there might be a circular aspect to what they're doing, it's very difficult to get across some of the arguments on things like product life extension. People get recycling, they get resource efficiency, so they get the closing of the loop, they get the thinning of the loop, but when it comes to the slowing of the loop, it's not that intuitive. A lot of people really don't understand it. So on things like the Critical Raw Materials Act, it's fantastic on recycling, 25% target, but trying to get across the importance of slowing down perhaps the use, or should we say product life extension, for some of the products and buildings and so on which contain those critical raw materials, difficult. Also difficult to know how we can actually do that at European level, but I hope that through our review of the Waste Electronic and Electrical Equipment Directive as part of the Circular Economy Act later this year, watch this space, we will be able to bring in some design requirements which will help to do that. Same goes for buildings. I think we've gone quite a way to and I think Josephine, my colleague, will talk about that later, to convince people about the importance of using recycled materials and of refurbishment even. But when it comes to things like modular and adaptable buildings, very difficult to get that across. So that's why modelling matters. We have plenty of good examples, and we tend to roll out the same ones quite frequently. But we need to have modelling to raise the quality of our judgment. When it comes to climate, as I think Vicky will be able to say far better, we started rather top-down with rather clear targets. With circular economy, I mean, if you look at the monitoring framework, we have a multiplicity of indicators, no real targets. So circularity is highly complex. We have many different questions to answer relating to where are bottlenecks in flows of materials, what are the distributional effects across member states, what happens, and these are some of the questions that you're trying to answer, what happens when we move from putting products on the market to more service-based models, what is the relative contribution of dematerialisation, and that's before we get to issues like the rebound effect and cross-sector dependencies and so on. The level of complexity in terms of circularity has evolved as our approach to circular economy policy has evolved over the years. A decade ago, we just used to ask the member states to supply their data to Eurostat every year for recycling and landfill, and then a couple of years later we might take them to court if they hadn't achieved the targets. That was relatively simple. Today, as we prepare the Circular Economy Act, we're really looking at stocks and flows of materials which, when they are traded as secondary materials, are commodities, and we need to have a proper understanding of what the effects of our policies will be. So, I mean, we have a particular KPI, we don't even call it a target, of the circular material use rate. Again, that is a fairly blunt one, it's just about recycling. But we will, as we go to in the immediate term, to the Regulatory Scrutiny Board with our proposals for the Circular Economy Act in a month or two, we will need to be able to make the case with some fairly good data and analysis. And we realise that we are struggling in many of those areas. I think we'll do a pretty good job. But then after that, we need to, when we actually apply these instruments, we need to understand what the effects will be in terms of the different policy instruments that we can use, and particularly the proportionality with which we use them. So Basically, I'm saying that what you're doing is extremely important. And I think the most important message that I would have to continue, is I'm getting red cards now, as we're two Brits on the stage, which is a very rare occurrence these days, representing the Commission. I wanted to make my final point, which is that you have to continue, and I really hope that, basically, my message is that I hope that this isn't the beginning of the end, but it's the end of the beginning, to quote our compatriot, our very famous compatriot. So good luck, and I'll stay around to hear more about what you've been doing.
Then from my side, so to look back at the climate picture, we had the 2040 target agreed in the amendment to the European climate law in March. It puts us on the path to 2050 climate neutrality. And now we're working on the details. And I wanted to do a little bit about what the impact assessment said, but a little bit more about where we're going in terms of implementation, because the evidence that you're providing is very important for that. As you know, the 2040 target was based on a detailed impact assessment. It showed the importance of the circular economy, how it's increasing in importance for reaching our 2040 targets, and of course beyond 2040 to climate neutrality, both for climate ambition but also for prosperity. We're always making the case for the economic, environmental and social aspects in our impact assessments. It also shows the increase in sustainable lifestyle choices can significantly reduce the efforts needed to decarbonise other sectors in the nearer term. And so it's also very important in terms of how we can use the policies that we're developing also to help bring about more efficiency, to improve material and resource efficiency. The transition we're looking at is a transformation of our economy, how we produce, the efficiency, the energy used, the materials used, the skills needed, and of course the investment needed. It's also very much about developing the solutions to allow more sustainable consumption. And so that's very important for us when we're looking at all the policy measures. We're now implementing, I have to say that in a post-Green Deal Commission, but there's, I think, probably more work than ever on the files that we're working on. It's a very, very busy time. We're working on a series of proposals now to implement 2040, so the full post-2030 framework. So it's a review of the ETS, review of national targets, so both ESR and LULUCF emissions or coverage. There's also new provisions on international credits, what we accept, what we don't, how we use them, review of the governance, review of renewable energy legislation, review of energy efficiency. These are all coming this year alongside everything that's happening on the circular economy, and so people are very busy, and I think the projects providing evidence which is integrated is essential in that context. We know that we need all sectors to contribute to get to climate neutrality, and we're looking at now the harder to abate emissions, and this is obviously getting this means that the debate is getting more and more fraught. We really need to come forward with good evidence. We need to, of course, getting to climate neutrality means being at net zero in 2050, but the climate law is also clear that we need to be at net negative afterwards. So it's about balancing remaining emissions and removals, but also addressing the over emissions that we have now to bring us back towards 1.5 and to 1.5 by the end of the century to limit the overshoot. Right now, the energy crisis is focusing minds. It's really reinforcing, again, the understanding of the importance of energy independence, of energy efficiency, the shift away from fossil fuels. It's being helped by the huge increase in uptake of renewables. We know that the power sector will lead in terms of timing, in terms of decarbonisation, and there's a lot of focus around investments in that area. But we know how important it is to also address materials in terms of the energy needs, but also in terms of what it means in terms of use of carbon and storage of carbon in buildings, etc. We need to create the right incentives. For example, for the land sector, for new products, we need to create new markets, lead markets, We also, in doing so, there's a big focus on bioeconomy, but also on bioenergy, maintaining biodiversity and sinks. And so it's very important that we get the balance right, that we address the trade-offs. And so this integrated approach is very important. And also, last but by no means least, is the international context. In the international context, there's an ambition cycle. Next year, we'll be starting the work to prepare for the global stocktake 2, maintaining ambition, showcasing solutions. All the evidence that's presented here is also important with our engagement with other parties around the world in terms of how to address global emissions. So we hope to have a very good discussion today. Unfortunately, I can't stay till the end, but colleagues, Marie is here from my unit, and other colleagues hopefully will drop in during the afternoon, and we'll let you get on with the discussion, because I think we've taken too much time. Thanks.
Thanks, that was very interesting to hear you both. Now I'm going to quickly invite Detlef van Vuren, from PBL and Utrecht University, professor at Utrecht, and representing also CIRCOMOD. I'm also going to introduce already to the stage Volker Cray from IASA, representing CircEUlar, and Ana Teresa Macas-Lima from DTU, representing CO2 Construct. Thank you.
Yeah, so thank you. So this is going to be a joint presentation from all 3 projects. And these projects, coming back one, yeah. These 3 projects responded to the same Horizon call about 4 years ago. And you can see that they started at the same time. We're now all ending at the same time, and we decided to do this presentation together. And even this presentation itself is bringing the 3 projects forward and just presenting an integrated story. And you can even see the logos of the projects are also quite similar. So it's nicely integrated. So we all know that there is the material consumption in the economy, and these materials provide a lot of services to the economy. And unfortunately, they also require energy. And traditionally, if we look at from a mitigation perspective, with the models, we look to how can we create these materials with different fuels, how can we make the energy efficiency of producing these materials more efficient, but we don't traditionally looked at, do we use so much materials anyway? And so the call was, let's see what potential is there for using less materials, and also consider what are the economic consequences of that, what could be incentives to do this, what could be barriers, and you see that the 3 projects have looked into this. And that means that we would move away from this linear use of materials towards a more circular use of materials. Now, what all 3 projects have started to do is to look at these so-called R strategies, but because it is a bit complicated with so many different options, we summarized it into 3 main strategies, which would be called narrow, slow, and close. And this will come back during the presentations. So narrow, using less materials by, for instance, changing your activities or using the materials more efficiently. Slow, use materials longer in the economy, increasing the lifetime, and close, recycling materials. You will see in the presentations that not all projects have exactly put the same interpretation of these strategies or have different policies there. So some of the results that are different across the projects you can understand in the way that we have, for instance, implemented the slow strategy. So I will first say a little bit, and this is based on the CircOMod part of this whole story, say something about the global and EU pathways. And so what we did, and the other projects as well, is looking into baseline use of materials. And this is in this case the global use of materials. You see steel, aluminium, copper and cement, and how they are used in a current policy scenario where you see that material use globally would continue to go up. We also looked then, not only in a baseline scenario, but what would happen to material demand if you combine it with climate policy. And the bad news there is that actually in the short term, material use would go up, simply because we have to build up a new infrastructure for renewable energy. And you can clearly see it, for instance, in the copper and in the aluminium trends. So that doesn't help. But we then also looked into what can we do with the recycling the circular economy strategies. And that makes a big difference because you can easily see how that would reduce material demand by quite a bit. We simply made an inventory of all the circular economy measures that we could find, started to implement them in these 3 strategies, and then find how actually this could reduce material demand. We also combined that then with climate policy, and you can see that still efficiency gain would still be there, and so material use would be lower, but also, therefore, the energy consumption, the energy need for producing these materials would be lower, which would help implementing the climate policy. We not only did this for the globe, that was the previous slides, we also looked in detail into the EU. All 3 projects did that for different sectors. This is from CIRCOMOD, where we actually coupled a detailed energy system model to a material flow model and making them speak to each other, and therefore also making these unique scenarios for Europe. And you see actually more or less the same picture as you would see from the globe, that here we have the different scenarios, the baseline, the circular economy, the climate policy, and the combined, that we can, with circular economy measures, significantly reduce the demand for materials. And that therefore, you can also benefit from that in the climate policy case. This is the steel, but we also did calculations for all kinds of other materials. In the global model, we can also look at different parts of the world. And while we see that there is some convergence in between the global south and the global north, we also see that actually throughout the century, the consumption of materials in the global north is still much higher than the global south. So there is still some gap. And then we started to look into what does it mean for climate policy. And what we see here are the CO2 emissions, and we actually also looked at the impact on the baseline, and then the impact is relatively large. In the case of the climate policies, so if you combine the circular economy measures with the climate policy, it's slightly more difficult to read the differences, and that's simply because we're already decarbonizing some of these production sectors anyway. So you do still get the resource efficiency dividend, you do get an advantage that you have to reduce a bit less, but it is a bit smaller because you are decarbonizing these sectors. So here you see the different scenarios for the world and the EU. And let's blow that up a bit and just focus on the differences. So if we take the world situation, and so in the baseline, we can start from the different strategies, the narrow, slow, and close strategies, and how they impact the emissions. Then we have the climate policy, and we have the circular economy, with climate policy clearly showing that the circular economy measures can contribute to this climate policy measures. In our calculations, and this is done from the CircOMod part, the narrow strategy is the most effective strategy. Thank you. And that is mostly because it's relatively fast to implement. We evaluated it over the next 35 years. The close strategy gives a little bit less, but it is mostly also because we look at these bulk materials where steel and cement are very important. Steel recycling is already relatively large in the baseline, and for cement there's a little bit less options. And so that is to explain why, particularly here, that strategy doesn't give so much as the narrow strategy. For the close strategy, in our scenario analysis, we implemented it for new materials. So and therefore it's only building up slowly over time, and that's if we would have run the full century, for instance, we would have seen a larger contribution from that particular strategy. I show the global results, I show the EU results, they're quite similar. This is the point of time that I will hand over to the next project, because that will start to focus in on a particular sector.
Thank you.
Thank you, Detlef. So now we come to the construction sector. The construction sector has been under the hot seat for quite a while about being the first one in terms of emissions. Not the one that you would like to be first at, but yes, that's where we are. So we focus this project on the construction sector, and at the European level as well. And what do we mean with construction sector for this project? We mean the building sector, the buildings, the offshore wind structures. Offshore wind, better? Great. Offshore wind structures, and most focused on material value chains. In this project, we also looked or used one climate mitigation model, the JRC EU times model, to estimate the carbon reductions. But we also then used other models to give kind of a red light or a traffic light response to other externalities, mainly environment, social, water, economic, and transport. So what do we mean with the materials for construction? We are talking about these 6 in particular: steel, cement, glass, brick, insulation, and wood. But of course, these are not only the 6 materials that exist. There's a lot of subcategories that are included in these material classes. So we did detailed value chain mapping of each of these materials that we mentioned to understand where the circular economy options were along these value chains. For that, we also mapped all the circular economy options that we found along these value chains. From that extensive exercise, we found 88 circular economy options along these value chains, not only the material value chains, but also the building and the offshore level. From the 88, 26 were quantifiable or found quantifiable for running our models. And only 17 of them are cost effective. And they are, you can see that they are highlighted by the arrow sign here in this extensive list. You don't need to really look too much into it. But then yes, we group these circular economy options into the narrative that Left already said. Narrow, slow, and close. And now we are going to show you mainly the results for SSP2. This is the dashboard. It's very busy, so good luck with that in 2 minutes where this slide is going to be on. But in terms of carbon mitigation, we can see that for final energy consumption, narrow contributes quite a lot, but that is a different message in terms of carbon reductions for the industrial sector. There, slow dominates. And of course, a lot of these results are preliminary. We are still working on our models. This is also based on the level of ambitions that we have set up right now for these results that we are showing to you today. And so bear with us, but these are the results that we want to show you. For the environment, again, slow presents the highest benefits. The social, in terms of employment, the slow is actually the one that shows the highest reductions in terms of employment, as expected. So, because again, the slide was very busy, I think this is much clearer of what it means. Stress is that with this model that we use, carbon mitigation is a reality, or carbon neutrality is a reality for 2050. But the way to get there, slow, gets us there better in the runs that we have tried. For all the options showed environmental benefits, and all the options showed that there's going to be less employment related to circular economy, based on the companies and the industry that we have today, not estimating what other industries are going to be there in the future. Also, the use of water is the best one for the slow scenario, and transport, we are still underway to understand what type of options we have can put or estimate for the narrow, but for now none of them show a very positive result. And with this, I think we move on to to you. You, Paul.
Thanks, Anna. Yeah, you've seen that the three projects have tried to look into the future in terms of determining what are effective circular economy strategies to get our emissions down, but we also realized that we are far from certain where we stand at the moment. So better characterizing the initial conditions as well as the boundary conditions of future change is also one of the objectives that I think all three projects have worked on. I'll show you a few examples here from the CircEUlar project, specifically, characterizing current material stocks and which services and sectors they relate to, then also better understanding which circular economy options or strategies are more likely to be adopted, or where the willingness of consumers is higher to adopt, and can we explain how this varies also across countries and strategies. And then the topic of rebound effects, where circular economy measures or enablers of circular economy can potentially also lead to partially offsetting or even increasing effects. When we think about material stocks, the two elephants in the room are, and you saw that I think in Detlef's slides already, mobility infrastructure, roads, railways, and so on, as well as buildings. That's where, in terms of mass, most of the material stocks are accumulated. This is the result of an assessment of current mobility infrastructures, basically uses spatially resolved information from the OpenStreetMap to understand the distribution globally. You can see that global north countries with low population density tend to have the highest per capita stocks, which are here shown and associated with darker colors. At the same time, there is a lack of mobility infrastructure in the global south, so there is going to be material accumulation happening. Most of European countries are somewhere in the middle here. And then when we look one step further, how this is distributed, the biggest portion, between roughly 80% at this macro region level, between 85 and close to 100% is accumulated in roads. Then depending on the region, railways can make up a substantial portion. China has a very large share. Europe's actually also relatively high there. And then parking lots or infrastructure related to parking correlates strongly with per capita vehicle adoption. So yeah, and then we use that basically as a starting point for understanding how this might develop further. Similarly to buildings, we've mapped European building stock, close to 300 million individual European buildings, including characteristics like building footprint, heights, usage type, structural type, material content. By bringing together information from government data sets, OpenStreetMap, satellite imagery, and so on, missing attributes are inferred with machine learning, and that enables location-specific, investigating location-specific retrofit strategies, also looking at urban form and urban planning as a measure to reduce emissions. So that's the EUBUCO data set here. Then, in terms of enabling conditions, the consumers, of course, play an important role in Europe. So we've run surveys with consumers here across 5 different countries to understand the willingness, in particular, also figuring out whether narrow strategies, which has, as the pathways show, have a big lever in principle, but what is the willingness of consumers to actually do this? Thank you. I was actually positively surprised that about 30% of the population surveyed here is willing to move to a smaller home. Important side sentence, if one was readily available. And that, of course, requires functioning real estate markets, which is a challenge. On the other hand, of course, there is also parts of the population who are less willing, depends also on the biographical stage that they are in. Looking at an example from the mobility sector, car shedding, so the willingness to give up a car if other options are available, like ride sharing, car sharing, and so on. Here, it looks much more conservative. So in terms of the circular economy, reducing the stock of cars, there seems to be less willingness across consumers to give this up. These are, of course, stated preferences, right? But it gives us an idea of what is more feasible and less feasible. And then in terms of enabling conditions, I mentioned car sharing. In principle, digital technologies offer an entry point or enabler to implement many circular economy, but also other energy efficiency and emission-friendly adoption. So we did an evidence synthesis from the literature, understanding what might be the benefits in terms of circular economy and so material and energy use, but also what might be rebound effects. And looking here, picking out a couple of examples, this is about building information modeling as a measure to make buildings more recyclable, retrofittable, and so on. Here, the evidence suggests that there's largely positive effects associated with that. On the other hand, if you look at a few examples from the mobility sector, there is a larger potential for rebound effects, so actually increasing emissions because of lowering opportunity costs of mobility options. Synthesized in pathways, the hatched area is basically a combination of current, this is global emissions. If we combine different digitalization futures that are either focusing on the enabling conditions or that are kind of not climate aligned, we see a very large potential impact on global emissions outcome, and also the achievability of the Paris targets could be largely affected depending on whether we can set boundary conditions that are aligning digitalization with mitigation action, or those actions that may actually lead to strong rebound effects. With that, let me end here, and thank you for your attention.
Thank you. We have time still for 1 or 2 questions. Does Azo can bring the microphone? Do we have questions in the room? Or do we see hands? Maybe online we have one question, I think. Or there's one question here.
Robert Marszynski from the Joint Research Center of the Commission. Hello? Yeah. No, I just noticed very interesting overall, but one striking result between the first and the second presentation was that in the first one, the narrow was the most effective circular economy strategy, and in the second, the slow came out as the winner, no? If I understood correctly. So, maybe you could comment on what explains that quite striking difference?
Yeah, so I was already hinting at it a bit because I had seen the results. So in our interpretation of the slow strategy, and maybe we have to reconsider that, but we assumed that if new materials were bought, then their lifetime would be extended. And so we didn't put the lifetime extension on the existing stock, we put it on new materials, which means that slowly this time extension goes into the economy. And I think that is a different assumption that was made in the CO2 construct project. The result is that in our case, this strategy becomes effective, but it takes time. And so if you run our scenarios over the full century, you see that that's also slow becomes an effective strategy. In contrast, narrow has this advantage that many of these measures can be taken on a relatively fast track, and therefore they give us this relatively large contribution on the short term. And maybe you can contrast why your results are different.
Thank you so much, Detlef, and thank you for the question. I think this is the answer to this question is much better answered by the modelers, and I just refer to you to the different sessions. Maybe you should split yourself and go into no, but what I would like to add from the construct side is that the level of ambition, and I think I mentioned it briefly during the presentation, the level of ambition that we considered for the narrow initiatives, for the narrow practices, are based on a citizen survey that we carried out, and therefore might be below the expectations that other projects considered. So,
there's another hand over there.
Hi, this is Jillian Fosser, also at the Joint Research Center. And I had a question about the strategies. So did you use the same set of strategies in each case? And how did you decide which were the effective strategies? Was the effectiveness judged first in terms of evidence for which strategies are more or less effective? And was there a threshold of effectiveness to end up in the list?
Maybe you want to go first, Volker?
And also, how did you model in the timing of the rollout of those strategies?
Yeah, this is a very good question. And I mean, we haven't fully harmonized across the projects. That's definitely one thing, and there are definitely borderline cases where one can argue, okay, this is fits into narrow. When you think of material substitution, for example, that's not necessarily a strategy that narrows material flows, but we can interpret as it narrows the flows of, let's say, the incumbent materials in the sector, right? But there is there is a gray area, and as also explained by Detlef just now, the specificities of the implementation is something that we haven't fully coordinated across the projects, and therefore some of the insights at high level need to be digested with care, and it's probably on us also to make sure that we are very specific about our interpretation and implementation of these options to understand. I mean, the slow strategy example is a good one, right? Whether you assume, okay, all existing buildings, we just put in additional maintenance, and that leads actually to material flow benefits in the short run, or whether we assume only new buildings that are basically constructed or designed for longer lifetime and maintenance, they get this benefit. It makes a big difference, like 40, 50 more years in terms of when the benefits start accruing.
Yeah. So answering also one part of your question, I think all three projects started with a kind of a literature review of the different options that are available. And so from all three projects you can find a whole database of circular economy options and the associated effectiveness as we assessed it. And we used it then, in our case, then to build up our scenarios and our strategies. In principle, that is done in all three projects, but as explained already, we looked at the literature, we then made slightly different interpretations of how to implement these strategies, and it's nice to put them next to each other. Narrow can be extremely effective, but if you consider some of the implementation that people are willing to do, that might be slightly less effective in that case. And the same with close. Close can be extremely effective if you apply it directly on everything. If you apply it only on new materials, it will be effective, but slowly over time.
If I have a few seconds to try to answer also your question. Thank you so much for your nice question. We did this bottom-up approach to circular economy strategies mapping. And one of the struggles that we had to allocate these different strategies that we found was the units of analysis, what we call units of analysis. So material unit of analysis is very different than building. And it was bound to have some repetition across the different units of analysis, which we took care of. So we had a special care for that, and that's why we narrowed it down from 88 to 26 that we mentioned there. So I hope that answers more or less the question.
Thanks a lot. I think we're running out of time here, but join me applauding our three speakers, and thanks a lot. I'll invite Sarah now to take over the next session.
Thank you, everyone. So I'm Sarah Georgie. I'm part of the CircEUlar team working at T6. We're doing the stakeholder engagement research. So this next part is an expert panel. So I'm going to be inviting on the stage the 3 panelists and 3 discussants. Could you all step up? I will introduce you, but you know who you are. So please don't be shy. Come on up. Take a seat. Yep. And Josefina as well. Would you like to join the stage? It's okay. We're trying to make this a little bit more dynamic. So you will hear basically a panelist and then a discussant. So it'll be like a conversation, and hopefully we'll still have time at the end for some questions. So it's on 3 thematic areas. First, we'll talk about construction ecosystems, then service-focused measures, and then system-wide enablers. So if I can kick us off on construction ecosystems with Pierluigi Zerbino, Senior Assistant Professor from University of Pisa, from Construct. And then responding, we will have Ruben Bibas, Economist at OECD. Pierluigi, the floor is yours. Like Marianne, I have my card, so I'll tell you when you're halfway through, when you have a minute left, and when you're out of time.
Right. Where's my presentation?
It should appear.
Yeah, I'm trying. All right. So, thank you for being here. Well, 2 years ago I visited Senegal and I got stuck there because of an attempted coup d'etat. So it was a great place, but I decided to take things slowly and to make the most out of it. Then I visited a village called Sipo. I met the king and the fellow teacher there, and this is the blackboard of the school. If you read it from the right to the left, that's the narrative of Construct, how we approached carbon neutrality through the circular economy. The alphabet, the scope, the narrative that we came up with. Well, about the alphabet, the language that we decided to speak, we took the JRC times model, we decided to augment it to make it able to forecast the impacts of the circular economy for carbon neutrality. And we decided to rely on data from material intensities, the building stock, also the voice of customers and the end customers, so citizens. And we also decided to interact a lot with industrial stakeholders through case studies, interviews, so we managed also to collect a lot of data about costs and material consumption, energy consumption, about the circular economy practices. And we tried also to do our best to validate data through industrial stakeholders, because that's a way to bridge modeling and real practice from the industrial world. And this was our playground. We considered the whole supply chain, from raw material extraction to the management of construction and demolition waste, and also the changes in the supply chain due to the circular transition. And here is the narrative. I mean, the circular economy can do the job. We can achieve carbon neutrality by 2050. And the circular economy could also allow us to save some very costly investments in carbon capture and storage technologies. More than 10 circular options resulted to be cost optimal. So they might be more costly than regular practices, but when you consider them not in isolation, but as a combination at system level, they deliver cost savings. And whatever we decide to do, we must start right now, and we must adapt our trajectory for decarbonization over time. So it's not just about scripting, that's about steering. And you know, also the use of electric technologies, for instance, electric arc furnaces in steel production, glass production, well, they work very well for decarbonization, for instance, in the case of steel production and flat glass production, and the use of secondary raw materials as production inputs for decarbonization also is a great strategy, for instance, the use of glass cullet and steel scrap. And also, we should be aware that system-level costs are not a barrier, do not appear to be a barrier. But to do so, the value chains of the construction industry must be ready. To do so, we have also 6 possible policy moves. The first one about selective demolition. Selective demolition is costly, labor-intensive, is low. We should try to scale it up. Second, the industry is not just about providing supplementary materials and secondary raw materials. Instead, also, these materials should be provided with predictable quality, predictable supply time, predictable information about the whole provenance. Third, well, when the competition for specific secondary raw materials is going to increase due to competing demands from different supply chains, this may entail additional material scarcity and price volatility. So we should try to anticipate this market effect. Fourth, the circular economy is not fair by design. Some circular economy practices could bring advantages to specific actors in the supply chain, but costs could shift on other actors. So we should conceive governance mechanisms trying to rebalance costs and risk on one side and rewards and benefits on the other side. The second to last, the circular economy is not just about thinking about ways to manage construction flows and material flows. It's also about the fact that it entails new activities, new tasks that requires new skills. So workers need the right skills and also the agency to perform across these interfaces, across logistics, operations, circular business modeling, circular supply chain management, and so on. And the very last possible way that we conceived is that the circular economy is not just about what constructions are made of. It's how we can creatively and intensively use the building stock. So we should try to use our lateral thinking and conceive new ways to increase the usage of our current building stock. And that's all from my side.
Can you hear me? Yes. Hello, everybody. So first, thank you for the opportunity to participate in this workshop, and thank you, Pierluigi, for this very inspiring presentation. First off the bat, I want to say I agree with the framing. The risk is not on the cost of circularity, but it's really on its implementation. And first, because we're looking at construction and buildings, why this matters, the built environment is decisive for net zero. It accounts for over 1/3 of total CO2 emissions globally. About 10 gigatons per year. You all know that, but this is not a marginal efficiency agenda. This is a systems transformation that we must make happen, and where there are bottlenecks that will determine the outcome. Second, I want to bring in some numbers that the OECD has published recently, so I'll try to not do too much self-publicity, but just to give you the rough picture. The pressures on materials is increasing. structurally, and it leads to an increase on environmental impacts that can be also linked to what has been called the triple planetary crisis, so climate change, biodiversity loss, and pollution. And our modeling, because this workshop was about modeling to policy, shows that global primary material use is projected to increase roughly by half to 2050 in a baseline scenario, so without additional policies, increasing to about 145 billion tons of material use that are extracted every year. And of that, construction is the main driver and is poised to also roughly increase by half. This will increase the competition between across the uses and sectors of primary materials, but also of secondary materials, which leads to a competition for pressure on quality and availability. And it's the frictions on the secondary materials that will be secondary material markets that will be key into realizing the transition towards a circular economy. Third point, economic instruments can shift the equilibrium, and we've done careful modeling of some economic instruments, including taxing primary materials and supporting secondary materials, that can reduce primary material use and incentivizing circularity. But as was mentioned in the presentation, and we're fully in line, there are issues that can arise. Impacts can be uneven across sectors, especially from material-intensive industries like construction. And there are risks of competitiveness and distributional effects. Yeah. A third point I wanted to make is that construction and demolition waste management must scale, so I think what you called selective demolition. So we're fully in line with that, and there is still a quality and reliability gap with a lack of trust in material quality, information on composition, and broader quality constraints. And the last point I wanted to make is that fragmentation is a real structural barrier. And one piece of evidence is that in 93% of the countries, the building decarbonization involved more than 3 different ministries. And the same type of misalignment applies across the value chain. Costs and benefits occur at different stages of the life cycle. Decisions taken at the construction stage affect very much the long-term outcomes, and I think that was already in the previous discussion highlighted. So there's a question of rebalancing costs and benefits. So yeah, thank you. I just wanted to again thanks Pierre-Louis for this presentation. We're very much in line, and if I may, I pose a question on this. Sure. Maybe we can go back later, but if you had to prioritize one policy lever, would it be more on the end of life and a push for traceability and quality standards for secondary materials, or would it be more on the use part, which is procurement and contracting reform to align incentives and share risks? I think that's... Thank you.
Yes, it works. So thank you for the question, Ruben. I believe that's very interesting because there are 2 sides of the same coin. In my humble opinion, selective demolition is a great enabler for very high value retention circular practices. So I would put my coin there. Because also it really enables to potentially reuse in the long run the building stock, to decompose it. Because when we talk about selective demolition, maybe the best word is deconstruction. So we really decompose the building, and I believe that's the stage of the supply chain where we should place our bet. And that's really the bottleneck at the moment because of possible contamination, because of the cost. But that's also the place of the supply chain where we have the most potential to harness, because selective demolition requires also new skills, This means new jobs, and also you can save money because you recover very high quality materials. And I mean, if I have to choose, yeah, you know, I'm going for the end stage for sure. And this does not mean that there is not any importance about the use phase. That's not the point. I'm not trying to create a ranking. Just the use phase has received attention, maybe more than the end phase, in my humble opinion. So now we should try to rebalance also this attention across the supply chain.
Thank you to Ruben and to Pierluigi. I like that the discussion's already begun. It's really good. We're all on the same page. If I can now invite on service-focused measures, Patricia Fortes, Senior Researcher at the Centre for Environmental and Sustainability Research, NOVA, and National Energy and Geology Lab in Portugal. And responding, we will have Josefina Lindblom, Policy Officer in Circular Economy and Secondary Raw Material from DG Environment.
Thank you very much and welcome here. Okay. Sorry. So, as mentioned, I'm Patricia from the CIRCOMOD project, and I will share some key insights from our modeling results related with these service-focused measures. And so, according to our models and this, which is, as I mentioned, this is a multi-model project, for EU and contrary to the other regions of the world, material demand is expected to stabilize overall. But however, there are some strategic materials that will have a huge increase. And I give you some example for copper. As you can see, our models indicate a decrease around 50 to 100%, so doubling, from 2025 to 2040. And this is under current policies. If we put deeper decarbonization, so carbon neutrality, a reduction of minus 90% in 2040, we see a further acceleration of this increase. For instance, if we consider the whole cumulative period from 2025 to 2050, metals will increase around 25%. And it's easy to understand why, right? So we are increasing renewables, we are increasing electric vehicles, and because we are electrifying the economy, of course, there will be a higher demand for these materials for the infrastructure. And in CircOMod, we have analyzed a set of C strategies, including the service strategies, which we can also call it this narrowing the loop strategy, as I mentioned. And maybe after I explain what we are considering, maybe it is clear why our projects has different outcomes comparing with the other project. For instance, these service-focused measures for us is delivering the same mobility service or housing service, but with less materials and less stocks. One thing is reducing, for instance, the activity, so lower floor spaces, so smaller houses, or lower mobility, so urban planning will allow that mobility to reduce, but also focusing the products, such as model shifts from cars to buses and rail, so more car sharing, so cars will have higher occupancy and higher mileage. So also physical optimization, so it's achieved to lighter vehicles and smaller, contrary with the trend that we are seeing in EU with the increase of SUVs. We also have assuming lighter buildings, new buildings, some material substitution, like for instance, substitute aggregates to recycle concrete, and of course, efficient at the industrial level, so reducing the fabrication wheels. And in the breakout rooms, of course, you will see more details and what we're considering in some of these measures. So overall, what we concluded in our project is that narrowing strategies show the largest mitigation potential, not just in terms of materials, but also in terms of greenhouse gas emissions. And just to give you some examples, for instance, for cars, these narrow strategies can lead to a reduction of 50% of the metals associated, which is linked, of course, to a reduction of the stocks needs. And for buildings, we also see a reduction of materials around 30 and 50%. When we look at the greenhouse gas emissions, and we are talking about already demanding an mitigation scenario, we see that the cumulative reduction of greenhouse gas emissions due to these narrowing strategies for the whole period, 25 to 50, will be 10%. And if you just look for 2050, where the carbon neutrality target is set, we see that could be a reduction of 20% of the emissions. So these narrowing strategies have a significant impact. And why maybe this is more relevant, and maybe answering a question before, sorry for this, maybe also because besides buildings, our project is also considering mobility, and of course this will have effects. Of course, that this reduction will affect not just materials and emissions, but will affect the whole energy and industrial system. For instance, we see a reduction with a narrowing strategy of 10% of the final energy consumption in 2050. And you should take into account this is already a high efficiency energy system because of the mitigation scenario. We see also a reduction of the CO2 capture needs in industry around 28%. This is a technology more costly end of pipe, so this is a positive aspect of this narrowing strategy as well. One key insight also, it's not just the materials reduction or the greenhouse gas emissions, there are other co-benefits associated, namely in terms, for instance, of air pollution, a reduction of some pollutions. I should mention, and you can also explore these in the breakout rooms better, that some of these numbers are more optimistic. So the material models, the integrated assessment models are more optimistic than our economic models due to, of course, the rebound effects that we have been talking about. But you can see better in the breakout rooms. So just to conclude, I'm very fast here. Just to conclude, if we look at historical circular economy policy, it has been mostly focused in the end of pipe, waste management, more recycling rates, and as already mentioned, for some materials, for instance metals, the recycling rates in Europe are already high. So they have, comparatively with these narrowing strategies, they have a more conservative impact on greenhouse gas emissions reductions. So our outcomes from our models, what they suggest is that maybe contrary, the narrowing strategy have this significant impact that I have shown. So these outcomes can suggest that besides this technology, they're always in the center of the climate debate, maybe this sufficiency and materials reduction should also be there. So we should also think about this. Another important aspect of these narrowing strategies is they are very challenging to implement, right? And so this car sharing, lower floor space, and we see in the first presentations about with the survey, there are people that are not willing, and of course because so this needs to take into account, of course, these behavior changes. And another thing is that these measures require, of course, urban planning, infrastructure planning, changing the transport system. So for you, and also leads to a reduction of some production. We see, for instance, a reduction of the car stocks. So balancing these narrowing strategies with industrial competitiveness in the EU and also the social acceptance, as we saw, may become a key challenge also in EU policy, and this needs to be taken into account. Thank you.
First of all, yes, here I should be. I got very excited when you finalized your work or your presentation with circularity and sufficiency. That's a forbidden word which we're not supposed to use. Better use of existing buildings, we say. But yes, it's super. I think what you're concluding is very much fitting into the conversations that we are having right now in different kinds of initiatives. I will explain how. we have, or in March, end of March, there was a staff working document that was published by the Commission, which talks about life cycle thinking, supporting that kind of life cycle approaches to decarbonize our buildings. It's not just decarbonizing, of course, it's also preventing waste or reducing waste at least, and considering land use and whatnot. So it has many different positives. We know how much new buildings impact on our climate because the upfront carbon peak there at the beginning is very high. About 1% of our buildings are being added each year, but they contribute to about 20%. That initial peak before the buildings have even been entered represent almost a fifth of the emissions from the sector as a whole in 1 year, right? Anyway, we have done similar studies to some of what we have heard today to build up that staff working document, and it's very much the same as you are presenting in terms of numbers and importance of different aspects. This document points to different kinds of measures, primarily policy measures, but also other measures. Very much linking to circularity, but also this forbidden word sufficiency. All right. When it comes to circularity, I think one thing that is very interesting now, it's all about the alignment of. It's all about setting, I think, performance requirements at the building level. Because if you set whole life carbon emission limits at the building level, but then you have to think about how you're designing your building, of course, and all that, but you also have to think about what material you're using, and that will lead you very often to use secondary materials. And I think that the current or the revised Energy Performance of Buildings Directive, which is now setting out including embodied carbon and how you have to take that into account, will lead to bigger circularity. Then when it comes to sufficiency, it talks about how to link those kinds of thoughts with climate plans, flexible zoning codes, and whatnot, so that you're bringing back your buildings, your vacant space, into the market. You mentioned, some of you mentioned reduced space for buildings, for housing. That's true, because they continue to increase, so at some point I guess we could stop increasing, right? But it's also about simply using the building that we have better. So there's lots of vacant and underused space. So it's not necessarily putting people in super small apartments. We're not going to Hong Kong necessarily. But there's really a lot of empty space out there, which we should use. And now it's red. Yeah. So just to say that there are lots of good examples in this staff working document where we can see how countries and cities, first of all, typically tackle circularity. But then they realize that it's not enough. It helps them in their carbon reduction goals, but they have to also go to sufficiency to reach if they have ambitious goals. So that's that. Just finalizing by saying that you're probably aware of the Affordable Housing Initiative, and you're aware of the New European Bauhaus Initiative. Both of those are very much looking into supply of buildings, of course, and they are also looking at this better use of existing buildings, right? So it's not all about building new. So we can continue to have those conversations there. Thank you.
Thank you very much, Patricia and Josefina. If I can invite now Yivan to speak on system-wide enablers. Yivan is Senior Researcher in Digitalization, Circular Economy and Net Zero in the Environmental Change Institute at the University of Oxford. And responding, we will have Mihai Palimarichuk, Team Leader in Fair, Green and Digital Transition at DG Employment, Social Affairs and Inclusion.
Yep. Thank you, Sarah, and good afternoon. So I believe most of us in this room would agree that digitalization is good news for circular economy, at least like more data, better tracking, smarter system. Yes, digitalization could bring us there, but it is not automatically. And I would say that it's not the default setting. So this is what I would like to talk about today: scaling the opportunity and managing the risk. So building on the narrow, slow, close narrative or terminology that presented earlier, digitalizations could enable all three of these, where different digital functions, as shown in this red box. For example, we have digital product passport and also BIM, Building Information Modeling System. And in some case, those digital tools do not just depend or do not just perform one particular digital functions. It consists more than one. For example, in the case of digital product passport, it has tracking, compliance, and data matching. And BIM does the same, but more for the built environments or the construction sectors. And it also adds simulation and modeling. So, digitalization as an enabler is real, but what I would like to highlight here is that the use case potential is not the system-wide outcome. First, it depends on adoptions. Currently, those circular enabling tool is slow to scale compared to what we refer as consumptions accelerating tools or digitalizations. For example, the social commercial platforms. So taking BIM as an example, the current adoption rate is around 31%, and it has not moved for more than 5 years, which means that the digital tool we need for environments lags behind. Based on our modeling, under the right governance, BIM is able to reduce the embodied emissions by up to 31% within 10 years. So what the main message which can be interpreted from here is that the model potential is here, it exists, but then it requires attention to enabler governance. What I mean is that we need to actively support those digital solutions with clear climate or circular economy benefits. Even with adoptions, it is not enough. It still depends on how wider impact unfolds. Both the direct footprints from the digital infrastructures, like the data centers or the different devices, and also the indirect footprints from applied sectors and the wider system. What I mean by this is that when we apply the digital solutions to, for example, building sectors or industry sectors or transportation sectors, are they going to decrease the consumptions, where the efficiency improvements, or it is going to increase the consumptions, overall consumptions, due to the rebound effect? It depends on how this direct and indirect impact play out. So, on the direct footprints, digital infrastructures that enabling circular economy has its own emissions. More crucially is that the digital consumptions that without any clear climate benefits is also growing alongside the enabler. And based on our projections, the global data center demand alone could be reach out to 5,500 terawatt hour by 2050. In general, it has a very wide uncertainty and growing fast. That is what about the electricity consumptions. We also have the material demand accounting as well, which will be shared in the breakout sections. But in general, the demand will increase by 5 times from the level in 2020. So the main message that I would like to highlight here is that currently we have EU AI Act, which is mainly focusing on the social or the safety risks of it. But we also need something similar for the environmental risk for the digital infrastructures. And then we also have the indirect footprints, which is even larger. Based on our assessment, it is 6 times, it could be 6 times larger than the direct data center footprints. So in one hand, it can reduce the energy demand by up to 23%, but there is also a risk that it could increase the energy demand by 25%. We assess it by referring to the same digital technology, The only differences are how it is going to be deployed and designed, and also governance. So for the direct footprints, we do have some like EU reporting obligations and the different governance framework. But indirect footprints, despite it's larger, it is the least governed part of the problem. So to bring this together, 3 different directions that pointed by our research. The first one is to promote or mandate digital enabler with proven benefits, so that we have the adoptions. And second, it is important to regulate the environmental footprints of digital infrastructures. What we have right now need to be strengthened and extended. And the third is to govern the indirect digital footprints, including the rebound effect of it. So without this, based on our assessments, digitalization risks a 35% emissions increase if without proper governance. I thought it could be an enabler, but the outcome is not currently. So these are what suggested by our research, but how to govern it effectively remain a question, and I'm looking forward to the discussions. Thank you.
Okay, thank you very much. It was a super interesting presentation. I made 2 kind of sketchy notes. I really liked the part on the adoption asymmetry and how the incentives are there for consumption accelerating technologies, but not so much on circular enabling ones. I was digging a bit through the research on BIM, and I thought it was super interesting the labor saving aspects on the return of investment. And for us at DG Employment, whenever we're thinking of adoption asymmetries, we're immediately thinking, okay, is skills and labor shortages a barrier? We know we're doing analysis, and we notice that a lot of maintenance workers are becoming in shortage, and I'm actually kind of wondering, and I hope we have a time to discuss about how the shortage of qualified workers will actually increase the incentives for adoption. So this is something that it's quite interesting, and perhaps we can collaborate more. The second point is on the governance, which I think I take your point. The rebound effects are indeed something that they're not always fully accounted for, and when we look at the governance, we talk a lot about how to use more renewable energy and how to make data centers more efficient. We do know that we have strategies to increase the number of data centers and to increase the number of AI use. And actually, it was the question that you ended on. It's also a question that I'm very much looking to discuss, because I think the direct is much easier to regulate. The indirect one it's a bit complicated, and I mean maybe the other discussants will have more to say about this as well. Look, I'm looking for more to the discussion than this. For me, the research that you've done was super interesting, and yeah, perhaps we can discuss more about how to plug it into policy. Thank you.
Thank you to all the speakers for adhering to the time. Before we kind of take a break, I know it's kind of, you've been sitting for a long time, but it would be great to kind of kick us off. I don't know if we want to start with the indirect and direct question that we ended on, or if there are other questions from the room that you would like to put to our panelists, or anything from people online. Nope. Okay. So in the room, any questions? Yep, Marie.
Yeah, hi, Marie Lemoyle. I'm at DG CLIMA, so I'm actually working in the team of Vicky Pollard, who gave the introductory speech.
I want to come back on one of the first points, or the first project that was presented, on the statement that many of these levers are cost effective, but from a systemic societal point of view, which I read to mean the cost benefits are kind of spread across the supply chain and are not cost effective at each actor level. And so my question is, what would it take to kind of build a business case for implementing these? So are certain benefits not monetized, in which case we can think of policy instruments to put a price on some of these things? And are there bottlenecks that prevent sort of cost pass-through, right? If there's one actor in this chain willing to pay for it, why is that not trickling along the supply chain? And are there policy instruments we can put in place for that?
Well, great question. Thank you for that. Well, I believe this first thing about developing a possible case, a business case, is to identify those parts of the supply chain, of those cases in which this could actually occur, because it's not going to occur everywhere. For instance, it could occur about construction materials in the flat glass supply chain, because if I use more circular economy, I, as a manufacturer, I'm going to benefit from that because I'm going to reduce energy consumption, which is very high, but I'm going to ask my customers to pay for that. Okay, so this is, I believe that the first thing is about finding the correct supply chain in which to potentially diagnose this issue, okay, which is very idiosyncratic. And second is to understand how costs might increase across the different stages. So it is not just about life cycle costing, but it's like coupling life cycle costing with value chain analysis. So to understand how value spreads across the different stages of the supply chain. So I believe these are the two main ingredients to do so. And then in terms, of quantifying these costs is not that easy, because generally companies are very reluctant to share cost data, and I believe this is true everywhere, in every sector, I would say. And also, the more material intensity is high, the more that value chain or supply chain might be prone to this kind of issues. So potentially industries characterized by continuous production could suffer from this issue more than others, because it's very hard also to separate the different lot of productions and so on. So this is my take about it.
Great. Would any of the other panelists like to react to that before we take other questions?
If I may, yeah. So I'm working on buildings more generally, sustainable buildings. And I've been in touch with companies and municipalities and whatnot for years now. And what I always hear from those who have been working on it for a while is that, yes, it came with a higher cost in the very beginning. But once you have changed your way of working, it's not more expensive. It becomes cost neutral, at least. So I appreciate the issue of it being more costly in the beginning. I'm not saying we should disregard that, but we cannot have these first timers, higher costs, stopping us from going ahead. I think that's very important to keep in mind.
Thank you, Josefina.
Hi, Marie Tamba from the Joint Research Center. I have a question that might cut across the three projects, so I thought I should ask it now before we split into groups. The projects all show that there's clearly synergies between the circular economy policies and climate policies. I wonder if the projects went as far as to have any conclusions on the timing and the sequencing, actually, of policy, because the climate policy has a pretty established cycle that we've been going through for a couple of decades, and do you have any conclusions on where the circular economy policy fits into that sequencing? Because we saw, that the energy transition itself drives material use. We saw that the acceptability is sort of an enabling condition. So any insights on the timing and the sequencing?
It's not an easy question. Would someone like to?
It's on. Sorry. Okay, so these are already were more or less mentioned in the beginning. So, for instance, these narrowing strategies have this first first effect, right, in the beginning, while measures like close the loop, so more recycling, because it takes more time to have these, to materials achieve this end of life, will take more time to act, so it have a higher effect later on, while this narrowing. But, as I mentioned also, it's not easy to implement these narrowing strategies, okay? For us, modelers, of course, so we go to the literature, we see what the literature mentions, we put some numbers on models, but the reality is much more complex. And for instance, most of these, as I mentioned, most of these measures are linked with different urban planning, different mobility systems, and this takes a lot of time to do it. It's not a fast thing to do it, right? So, so to be honest, I think most of them in the short term will be more hard, but in the long term, I think circular economy has a huge impact, okay? And in the reality, not in the model. In the modeling, of course, narrowing, but in the reality, I think all of them will have a major impact later on.
Before I take another question, can I just ask, does anyone want to comment on like the policy cycle, so where the circular strategies could fit with the policy cycle, which I thought, no. Yeah.
If I may, well, maybe I'm the demolition guy, so please focus on selected demolition. That's really, in my humble opinion, a priority for that. I know that there is attention about that topic, but that's really the way we could unlock additional value. So it's not just about environmental pressure. This is about potential cost benefit or cost savings. And this is very important also if we think about the gap, the value gap that was conceived in the last circular economy report in 2026. So the amount of money that we can lose because we remain linear, okay? So I believe that the most of that potential comes from the end of life stage. So in my humble opinion, the priority should be there.
Can I invite the gentleman with in the second row with the white shirt? Thank you.
Yeah, Edgar Hedwig, my name. I was one of the authors, together with some other people in the room here, of the International Resource Panel report that was mentioned in the call that we all answered to. And in that report, my colleague Reed Lifset at Yale University investigated the policy aspects also of sufficiency of housing, which I want to talk to because it is an issue that has occupied me. There is a lot of structural redundancy that is mostly due to structural effects that can be addressed through fiscal policies. We have very high transaction costs of moving, both in the rental market and in the ownership market. In Austria, where I live now, it's about 8%. And more than half of that can be removed by shifting taxes from the time when you shift to or move in to the time when you actually occupy the building. We have lots of 120 square meter apartments that are where a single person lives. Why does that happen? Because it's more expensive to move to a 60 square meter apartment than to stay where you are right now. And the new development where I live now, there are several flats that are unoccupied. Why does that happen? Because somebody placed the money there and it is actually not attractive to rent out. Because they don't have an operation to do so, somebody who will take care of it. And if they ever need this or want to dispose it again, then they have somebody who has a right to live there, right? And so, and that reduces the ability to turn over. So I think, and there I have to criticize the EC because we have seen a number of project calls on housing sufficiency in the Bauhaus, and none of them has addressed these issues. They're all about finding where the empty flats are. Well, what do you do when you know where the empty flats are? Are you going to knock and say, well, please sell the flat or rent it out? I mean, the municipalities can't do anything. In Austria, Innsbruck has tried to, or has implemented tax on empty flats. They need to ask people, do you have an empty flat? Because they cannot actually process the data to identify the empty flats because of data protection laws. So I think that there are some structural issues that need to be addressed here, and we should really think about the levers that can really make a difference. Thank you.
So another question just next to Edgar. It was more a comment. Were you expecting a reaction from the panelists, or?
I was expecting to answer, but
perfect. Go for it, Josefina.
No,
go for it.
Yeah, no, I agree. I did find it funny, though, that you said the problem is not that to identify the empty space, but then at the end you said we don't know where the empty space is. So, but anyway, I think it's about a lot of those things. I agree with everything that you said, of course. It's a topic which is new to us to drive forward, but we are doing it now. We have had some small studies in this regard, and right now I'm leading a big study on sufficiency. So I'll be very happy to talk to you afterwards, where it's not just about identifying the buildings, but it's also, or the vacancies, I should say, or more than vacancies, it's also the space which is not well used, right? As you said, the 140 square meters for one person. But it's also about finding the regulation, as you said, of different sorts that blocks these spaces being brought back to the market. And that's certainly also taxonomy, but there are many other things as well, as the zoning codes or whatnot. So we're talking to cities who are working on this very directly. But of course, the taxation we don't have competence to deal with, right? But it's something that we should at least point to. And I think that this is a subject which 1 year ago the Council wasn't talking about it, the Parliament wasn't talking about it. I think I was one of the few ones in the Commission talking about it. Now everyone's talking about it. So I think we're getting there, but we're not the fastest ones, perhaps.
Thank you. Good afternoon. I'm Helena Rook-Podolsky. I work for ICLE Europe, the global network of cities. So in these conversations, we're looking at material reduction. But a question I had and didn't see in any of the models is the skills aspects. So from what I've seen in different projects, especially on construction, you can have on paper a very good building that will reduce emissions, can be deconstructed, but then the use phase and how it's actually used is different. So did you do in the models any calculation of if the labor force is trained to have the circular economy skills to deconstruct, to use new types of materials, etc.? For example, you mentioned in cars that you want to sort of switch to having lighter cars with less materials. That also includes design skills. So how do you train the workforce so this becomes common practice, not just a few groups of companies that can do it in the market? So to what extent was this looked, and the skills aspect and rescaling of certain workforce? So thank you.
Who would like to take the skills question?
This work. Okay, the question was on the modelers. So, but I will say maybe what we do in DG Employment, because I think these are exactly the questions that we are thinking about. So in my unit, for example, we have this Fair Transition Observatory, and within it we try to look at measuring labor shortages for different kind of industries, and we're trying roughly to look at the clean industrial deal, but go a bit further, and also, for example, we want to integrate a lot more on circular economy into the future. So we're trying to match this, pointing towards labor shortages to see where are the barriers towards wider adoption of these practices. So this is a bit the world that we are driving forward. And then I can only agree with what you were saying in terms of how to drive skills. What we're doing is that we are financing different social innovation projects that are trying to use to try to create new curricula and to look at different ways of retraining people in the circular economy. It's a process that needs to start with innovation and then with scale up. And of course, there's, apart from our observatory, there's also a skills and forecast. There's a separate strand which is also working much more specifically at the types of skills needed. So this is the kind of work that we like to do in DG Employment, and we're also trying to mainstream it a lot on other colleagues. So, for example, in the Circular Economy Act that will forward, we've been, trying and working to showcase that skills are a barrier and that there needs to be actions taken there as well.
Okay. I'm very conscious of time, but would one of the modelers from one of the projects want to say anything on skills and how they were or were not included in the modelling? Any takers? Even?
Okay. So, of course, then in the materials and integrated assessment models, this is a thing that we cannot incorporate. But in our economic models, we try to mimic. It's very hard, as you can imagine, but we try to do it for sure. And maybe in the session about more the economic aspects and rebound, you can see more details about it. I hope.
Perfect. Okay, so I'm very conscious of time. I just wanted to take the kind of a round of applause to all our panelists. Thank you very much for doing this. So, as already been mentioned, these are teasers to what's to come in the breakout groups, and just a reminder of the room. So if you're looking for the systems enablers, you're coming back here. We will be 10 minutes late, so we're meant to come back here at 3:20. We'll come back here at 3:30. So for the systems enablers, they're here. If you're going to the construction ecosystem, you're in Netherlands 1. And if you're looking at the service-focused measures, solutions for mobility and housing, you're in Netherlands 2. So thank you very much. One last thing that we forgot to mention is in the break upstairs, there are 3 laptops where we've uploaded kind of interactive outputs that you can play around with. So some of the, like the Uboko website that Volker mentioned, and some of the other works that the other projects mentioned as well, they're there, and there'll be researchers hovering around to help you kind of play around with the data so you can look at what was produced. Thank you very much, and we'll reconvene at 3:30 in the different breakout groups. Thank you.